In this video, we are going to start talking about our quadratic functions, and specifically we're going to look at just our general form and some of our key features. These are called quadratics, and the important thing here is that a quadratic function is a polynomial function of degree 2. We have been multiplying with these, and we have been factoring these. This time, though, we're not just going to look at the trinomials. We're going to put an f of x on it, and we're going to graph our values. So this is what our functions are going to look like. They're going to look like f of x equals ax squared plus bx plus c. This part should look familiar. The a cannot be 0, because if it was, we wouldn't have that squared term. So this x squared is what makes it a quadratic function. Now we're going to take a look at our parent function. And what our parent function means is that it is our most basic form of a quadratic. So you can see here my equation is f of x equals x squared. I'm going to find coordinate pairs that make this equation true, and I'm going to do it with a table of values, at least here initially. Eventually we'll learn some other methods, but right now we're just going to do table of values. So here's my table of values. I've randomly picked values for x. This is my function, f of x equals x squared, and then I'm going to write them as a set of points. Then I'm going to plot those points, and that will give me my function. All right, so I'm going to come and I'm going to plug in -2 in for x. So I'm taking out the x, I'm plugging in -2. I'm using parentheses, that's important because -2 squared is -2 times -2, which is +4. So that gives me the point -2, 4. Now I'm going to plug -1 in. Again, I'm plugging it in right there. So I'm taking out the x, I'm plugging in -1, and that's giving me 1. So that ordered pair is -1, 1. Now I'm plugging in 0, so I'm taking out the x, and plugging in 0, 0 squared is 0. So that's 0, 0. I'm plugging in the 1, so I'm taking out the x, I'm plugging in 1. 1 squared is 1, giving me the point 1, 1. And then I'm taking out the x, plugging in 2. 2 times 2 is 4. So that's giving me the point 2, 4. Now it occurred to me that some of you might not understand where this is coming from, so I want to make sure we understand. I'm plugging into this x squared, because that's my function. I'm plugging -2 in for x, so this is -2 squared, which equals 4. So this point is coming from this value for x. This is my y value, because that's what I get when I plug in for the function. Then I'm plugging in -1. I get 1. -1 times -1 is a +1. This point is coming from right here, -1, 1. That's my point. Then I plug in 0, 0, 0. And then I plug in 1, 1, 1. And then I plug in 2, 2, 4. So that's where those points are coming from. Now I'm just going to plot them. So -2, 4. I'm going to count to the left 2 and up 4. So this point, this first point, is right there. Then I'm going to do my second point here. So -1, 1. I'm going to go to the left 1 and up 1. So right there. And then this point, 0, 0. And then 1, 1. So I'm going to go to the right 1 and up 1. And then 2, 4. So I'm going to go to the right 2 and up 1, 2, 3, 4. Now, when I connect and extend through, notice this isn't a line. This one's actually called a parabola. We'll write that down in just a second. But what I want you to notice when I draw this, it is going to be a smooth curve. It is not linear. I am not just connecting the dots. It's going to kind of look like a U. not sharp. So it's curve. It's a curve. It's not this. It's a curve. And that is our parent function. This is in general what all of our parabolas will look like. This is in general what they will all look like. We'll talk about how they're going to change as we go through, but that's how they're going to start. Okay? Now, the U-shaped curve that we have here, that's called a parabola, P-A-R-A-B-O-L-A, not a parabola, parabola. And there are some key features. Just occurred to me, I might be going a little fast, so I'm going to pause for just a second and make sure that you have time to get your graph completely done before we talk about our key features. All right, our key features of the parent function. We're going to define these key features in just a second, but when we're talking about a parabola, the things we're looking at are our vertex, our axis of symmetry, our zeros, and our y-intercept. The vertex is that point right there where my graph changes. See how I'm coming down and then I'm going back up? So that point right there where our graph changes is our vertex. For our parent function, that is at the origin, so that is at 0, 0. Now, our axis of symmetry is the vertical line that divides my parabola in half. You'll notice that my parabola has reflectional symmetry going straight through the vertex. Whoops. Okay, I think that's a little better. So right there, this vertical line, maybe a highlighter would do better. This vertical line going straight through my vertex is my axis of symmetry. Now my axis of symmetry divides it so that it's directly in half. It's always going to go through your vertex. It's always a vertical line, so it's always going to be x equals something, and that something is always going to be the x coordinate. So for our parent function, that is x equals 0. Our zeros and our y-intercept are actually the same. For our parent function, it's actually the origin. Since it's at 0, 0, our intercepts, our x-intercepts is 0, just 1, and our y-intercept is also 0. Now let's formally define some of these things. So I'm looking at this parabola. Don't worry about this stuff. We're going to talk about all of that later. But let's look at our graph. So we're going to do some definitions here. Hopefully you'll be able to see somewhat. All right, so first of all, parabolas can either open up or open down. You'll notice that this one opens down. See what I mean by that? Our parent function opened up. This one opens down. The axis of symmetry, which we just talked about, is the vertical line that divides the parabola into 2 equal halves. It also intersects the vertex. The equation will always be x equals a number, and in fact, it's always going to be x equals the coordinate of the vertex. Okay, so we're going to label our axis of symmetry is this line here. So our axis of symmetry is this line here. Okay. The vertex of a parabola is the point where the axis of symmetry and the parabola meet. It is also the point that is the maximum or minimum of the value. We're going to talk about those two words and when is it a max versus when is it a minimum. But for now, we're just going to look right here. This is our vertex. So our vertex is right here. The y-intercept is where the graph crosses the y-axis. This is where x equals 0. Notice that this one is the same as our y-intercept if it were a linear equation. To find your y-intercept, no matter what, you always let x equal 0. In this case, our y-intercept is right there. So our y-intercept is right there. And then the last one, zeros, can also be called roots or x-intercepts. And this is where y equals 0. So with our linear functions, we did x-intercepts. We're now adding that vocabulary to that, zeros and roots. It's still just where y equals 0. So our y-intercepts, our x-intercepts are here and here. We also call them zeros. Now on this particular example, our vertex right there is the point 2, 1. Our axis of symmetry, it's the vertical line that goes through the vertex. It's always going to be x equals, and in this case, x equals 2. I know x equals 2 because look at where I'm crossing on the x-axis at 2. It's also the x coordinate of my vertex. For my zeros, I'm not going to write them as points. I'm going to write x equals. So I'm just looking at the x coordinate, 1 and 3. So my zeros are right there, 1 and 3, because that's where I'm crossing the x-axis. And my y-intercept is right there. So in this case, my y-intercept is -3. These are the key features that we look at anytime we're looking at parabolas, which are the graphs of our quadratic functions, our x squared.